with Mr. Thomas.
Woohoo! Here we are with Chapter 9, Integration. This is Lesson 1 and it's an introduction to integration. So what is integration? Well, there's an area of maths known as calculus. This is a word you may have come across, and calculus is split into two key topics. These topics are differentiation and integration. Differentiation you have come across, we did this in Chapter 6, and integration is basically just the opposite of differentiation. So if you're given a function, f of x, you can differentiate it to find f dash x, and if you're given f dash x, you can then integrate it, and you can go back the way to find f of x. When you are integrating, we use the notation something like that. Okay, this is how you write it. So we've got this sign here. This is your integral sign. It means you are integrating. You'd be integrating your function, and dx means with respect to x. So your function will be written in terms of x. The way you read that is you're integrating the function with respect to x. And as I just said, that would be if your function was in terms of x. If your function was in terms of m, you'd have dm. If your function was in terms of t, you'd have dt. So, differentiation, and integration. To differentiate, if you remember, you multiply by the power and then you decrease the power by 1. What do you do then if you integrate? Sammy, take it away. Brilliant, well done. You just do the opposite. So you increase the power by 1 and then you divide by the new power. However, let's look at this example here. Let's say we've got a function, f of x, and we want to differentiate it. So let's say you've got 3x squared, take away 4. If you differentiate that, what do you end up getting? Good, 6x, perfect. If you have 3x squared plus 10 and you differentiate it, what do you get? Good, 6x again. If you differentiate 3x squared, what do you end up with? 6x. Perfect. If you look at it though, every single one, when you differentiate them, you end up with 6x. So how can you integrate to go back to 3x squared take away 4, or 3x squared add 10, or just 3x squared? This is where Ryan's face is probably like this, or this, one or the other. I don't know which one. So whenever you integrate, what you've got to do is you've got to show that there was possibly a constant before you differentiated. So to show there was maybe a constant, what you've got to do is you have to include a plus c whenever you integrate. And this is known as the constant of integration. So if we were integrating 6x, we know we would get back to 3x squared, but we also have to include a plus c. Again, this plus c shows you that there may have been a constant just on the end. So let's try some examples of that. So as I just said, to integrate, you increase the power by 1 and then you divide by the new power. If you had then x to the power of n and you were integrating that, well, you add 1 to the power, so it goes to n plus 1. So you'd have x to the power of n plus 1. You divide by that new power, so you divide by n plus 1. And what do you need on the end? Plus c. You've always got to include this plus c. Here, if you had n could be any value you want, but it can't be -1. Because if you add to the power, -1 add 1 gives you 0. So you'd end up with x to the power of 0, and then you'd be dividing by 0. And remember, you cannot divide by 0. If you did have that, then you integrate it a slightly different way, which you look at, not in higher math, but in advanced higher math. So you'll have to wait until next year for that. So some examples. Let's integrate x to the power of 6. Integrating, so you add 1 to the power, so it goes to x to the power of 7. You divide by the new power, so you divide by the 7. And what do you need on the end? Plus c. You got it. Example 2. Let's integrate 4x to the power of 11. So integrating this, do the same thing. Increase the power by 1, so the power is 11. Add 1, it goes to x to the power of 12. The 4 just now would just stay as it is. We're just ignoring that. And after you've increased that to 12, you would then divide by 12. And again, on the end, you need that plus c whenever you integrate. We're integrating here, so you need plus c. You can simplify that though. If you have 4 over 12, 4 twelfths just becomes 1/3. So really you'd have a 1 in the top, which you don't need to write, and you'd have a 3 down here in the bottom. So that is what you would end up with. You may want to write it a slightly different way as well. If you've got x to the power of 12 divided by 3, if you're dividing something by 3, you're really taking a third of it. So it's a third of x to the power of 12 plus c. You don't have to do that, it's just another way it may be written. Example 3. Let's integrate 3 with respect to x. Now this one, there is no x term, we're just integrating 3. We're not integrating 3x squared or anything like that. So if you're just integrating 3, well really our x term is going to be, we're integrating 3x to the power of 0. That's another way of writing 3, because our x to the power of 0, anything to the power of 0 is just 1, so that would just become 3 times 1, which is 3. So that's how you want to write it. If then you integrate it, well, it would be adding 1 to the power, so it would become x to the power of 1. And then we divide by that new power. So you'd have 3x to the power of 1 divided by 1, which will give you that. However, with the 3 and the 1, well, you could just write that as 3. And x to the power of 1, you can just write as x. So you've really just got 3x. And again, you've got the plus c. Really, the rule is if you're just integrating and you've only got a number, all you do is you put an x beside it, if you're differentiating with respect to x. So if you're integrating 7 with respect to x, it would just become 7x. Integrating 19 with respect to x, it would become 19x. Integrating pi with respect to x, it would be pi x. And again, for each one of them, you'd always have plus c. Example 4. Integrating m to the power of negative 5 dm. This time, it's the m that we're going to be adding 1 to the power of and dividing by the new power. So in the end, we've got dm. So here, again, add 1 to the power whenever we integrate. So we've got negative 5 add 1 is a negative 4. We divide by the new power, so we divide by negative 4. And what do you need on the end? Max plus c. Well done. So from there, we've got m to the power of negative 4 over negative 4 plus c. You can again write that a different way. If you're dividing by the negative 4, you can take the negative outside, so it's the negative at the front. Also, if you're dividing by 4, really you're taking a quarter, and then you've got the m to the power of negative 4 plus c. And sometimes what you may have to do, or you may want to do, it may make the next part easier if there was something else to do, you may want to write m to the power of negative 4 with a positive index. Remember, to change the index from a negative to positive, or vice versa, you want to move the base and the index from the top of the fraction to the bottom, or vice versa. So here you would have 1 would stay in the top, 4 would stay in the bottom, and this m to the negative 4 at the side, really you're imagining that in the top, move it to the bottom, and it become m to the power of 4. And again, you need plus c. Example 5. Integrating x to the power of 2/3. Again, with respect to x. Integrating, add 1 to the power, so 2/3 add 1. Remember the quick way of doing this. All you have to do is do top number, add the bottom. So numerator, add denominator. If you do that, 2 add 3 is 5. So if you add 1 on to 2/3, it's 5/3. So we have x to the power of 5/3. Divide by the new power. So we're dividing by 5/3. And again, you need plus c. From there, well, it's very, very ugly. It doesn't look good. You've got fractions within fractions. It's a mess. So to tidy it up a bit, you could think, well, I'm dividing by 5/3. And when you divide by 5/3, you would have done this years and years ago. But to divide by the fraction, you turn the one on the right upside down, which would be the 5/3. Turn it upside down, you get 3 over 5, and you would then multiply. So it's the same as multiplying by 3/5. So you could say that would be 3/5 times that x to the power of 5/3. And again, put plus c. You need that whenever you integrate, and then put it right the way down. Example 6. Integrate t to the power of negative 1/2 dt. Again, you've got dt because over here our function is in terms of t. Add 1 to the power. So this time you've got negative a half, add 1. So take it as negative 1 and then add 2. That obviously gives you 1. So negative a half, add 1 will give you positive a half. After that, you divide by that new power. So we divide by a half. And you've also got plus c. Again, you've got fractions within fractions. It's a mess. So for when you divide by the half, it's the same as flip it upside down. So divided by a half becomes times by 2 over 1. In other words, just times by 2. Writing that out, as I said, it becomes 2 over 1. So you can multiply by 2 over 1. You probably don't need to write divide by 1. You're multiplying the t to the power of half plus c. 2 divided by 1 just becomes 2. So you've got 2t to the power of a half plus c. And then from there, what else could you do? Isla, tell us. Well done, Isla. So you'd have 2, and then t to the power of a half means the square root. So it's 2 times the square root of t plus c. Example 7. Integrate 1 over x to the power of 4 dx. So this time we want to integrate that, but how do you do it? You cannot just add 1 to the power and then think that's x to the power of 5 over 5 and it's 1 over x to the power of 5 over 5. You can't do that. Okay, so forget about that. Put it out your head. What you need to do sometimes is you have to rearrange a function before we integrate. You have to do that if x is on the bottom of the fraction, and you also have to write your square roots, cube roots, fourth roots, and so on. You have to write these signs as fractional indices. So always have a look at your function. If x is ever on the bottom, you have to rewrite it. If there's ever a square root or a cube root sign, you have to rewrite that as well. So here, x is on the bottom, so you can't integrate straight away. So you would say, I'm going to integrate, and if you rewrite that, well, you can move that up to the top line. But remember, if you move the base and the index up to the top, the index would go from a positive to a negative. So you can rewrite that as x to the power of negative 4. From there, well, x is not in the bottom. We don't have any square roots, cube roots. So now we can integrate. Make sure for this bit, you've still got your integral sign and you've still got dx because we haven't integrated it yet. From there, add 1 to the power, so that becomes x to the power of negative 3. Divide by the new power, so we divide by negative 3, and include your plus c. From there, if you divide by the negative 3, you could put the negative at the front. Dividing by 3 is the same as taking a third, and that's x to the power of negative 3 plus c, that's really staying. Again, you might want to write it with a positive index, so the x to the power of negative 3 would move down to the bottom beside the 3, and the index would change from a negative to a positive. So you have negative 1 over 3x cubed plus c. Example 8. Integrate 1 over 5g cubed dg. This time we have dg because our function is written in terms of g. Again, when you integrate, you have to make sure that x, or in this case g, is not in the bottom of the fraction. Here it is, so you have to rewrite that. So you can move the base and the index up to the top line. Doing that, the 5 would stay there, the 1 would stay there, but the g to the power of 3, that would move up to the top. So you'd have 1g to the power of, and remember the power would change from a positive to a negative. So you've got 1g to the power of negative 3 over 5. You might want to write that slightly differently. You could have the 1 staying, the 5 is staying, so they're not moving, and it's just the g to the power of 3 that would move up to the top, or you can even just put it at the side. If you do move it, remember the index would change from a positive to a negative. From there, add 1 to the power, so negative 3 add 1 is negative 2. You can write that by saying that the fifth would stay as it is. We're not doing anything with a fifth. It's only the x or the g or the t or whatever your function is written in terms of that we're adding 1 to the power of. So the fifth stays. G would go to the power of negative 2, and we divide by that negative 2. And again, you need plus c because we're integrating here. After that, just multiply the numerators, multiply the denominators. So you've got the negative at the front, just move that out. 1 times g to the power of negative 2, it's just 1g to the negative 2, and 5 times 2 is obviously 10. Again, you could write that with a positive index, just move the g to the negative 2 to the bottom of your fraction, and it becomes g squared. So you end up with negative 1 over 10g squared And again, you need plus c. Example 9. Integrate 1 over 2 times the fourth root of x cubed dx. So this time dx because our function is written in terms of x. Again, we can't integrate if x is in the bottom of your fraction or if there's any square root signs. They've got to be written as fractional indices. Here we've got the fourth root, so because we have one of these root signs, we have to rewrite that. So first of all, I'd probably rewrite the fourth root of x cubed. Remember, when you're doing this, because you want the fourth root, it's going to be x to the power of a fraction, and you're going to have a 4 on the bottom. The root is going to go in the bottom. Think of flower power if you've watched that video. And because it's x cubed, that's the power, rhymes with flower, that's at the top, so you'd have x to the power of 3 over 4. If you move it up to the top though, well, the half would stay as it is, 1 stays there and 2 stays there, and it would become x to the power of negative 3 over 4. Because you're rewriting that as x to the power of 3/4, and you're moving it up to the top, so the 3/4 would become a negative. From there, we haven't integrated it yet, so we've still got the integral sign, still got dx, but now we can add 1 to the power. To do that, the quick way again, take that as negative 3, add on 4, you get 1, so that would become x to the power of 1/4. Divide by that power, so our half stays as it is. X to the power of negative 3/4 becomes x to the power of 1/4, and we divide by that new power, so we divide by a quarter. We need plus c because we've now integrated. From there, if we're dividing by a quarter, same as the other examples that I have done, if you're dividing by a quarter, you can flip that upside down. It's the same as multiplying by 4 over 1, or just 4. That is what you would end up with. From there, you've got a half times 4 over 1. Really, it's a half times 4. A half of 4 is just 2. X to the power of 1/4. You've got x to the power of a quarter, and then you need plus c as well. You could again write that as the fourth root of x if you want. So 2 times the fourth root of x plus c. It's the same thing. Example, I should have said, the dot here just means times. So that means a half times that x to the power of a quarter divided by a quarter. Example 10. Integrate the square root of x plus 1 over the square root of x. So with this one, again, you've got x in the bottom of a fraction, and you've also got your root signs. So here you need to rewrite them and change it. So x to the power of what? Good, that's going to be x to the power of a half. That's also going to be x to the power of a half. But because that's on the bottom of your fraction, move it up to the top, so it become x to the power of negative a half. So that is what you would end up with. Again, keep the integral sign, keep dx. We have not integrated yet. From there, x to the power of a half, you can integrate that. If you add 1 to the power, well, a half add 1 is 1.5, which is 3 over 2. Or just do 1 add 2 is 3, so it becomes 3 over 2. Again, so that's x to the power of 3 over 2. Divide by that new power, so divide by 3 over 2. From here, negative 1/2, if you add 1 to the power, so negative 1 add 2 is 1, so it's 1/2. Divide by that power, so divide by a half, and then you also need plus c. You probably want to tidy this up a bit. Again, you don't want fractions within fractions. So if you're dividing by a fraction, turn that upside down and change it to multiply. So from there, dividing by 3 over 2 is the same as multiplying by the 2 over 3. So this here would become 2 over 3 times that x to the power of 3 over 2. Plus, dividing by a half is the same as multiplying by 2. So that would become 2 times x to the power of a half. And again, you would have plus c. Next one. Example 11. Integrate x plus the square root of x in brackets squared. So with this one, you want to think, right, well, because I've got something in the brackets and I'm squaring it, the best thing to do would be to just multiply out the brackets first of all. So we're not integrating yet, so keep your integral sign just as it is. Keep dx just as it is. And you want to think, if you have x plus the square root of x, well, that's just when you have your double brackets. Also, you know you can't integrate when you've got any root signs. So rewrite that as x to the power of a half. So that's x plus x to the power of a half, and now multiply out your brackets. If you do that, you would have x times x. If you do that, that is going to become x squared. After that, if you do x times the x to the power of a half, when it's the same base, you add the indices. So it's x to the power of 1 times x to the power of 1 half. So 1 add a half, again it's 1 and a half, or 3 over 2. X to the power of a half times x just becomes, again, x to the power of 3 over 2. And if you've got x to the power of a half times x to the power of a half, it's the same base, so add the indices. A half add a half is just 1, so it's x to the power of 1. You don't even need to write that 1. From there, gather your like terms. So we've got x squared, well, we've just got x squared. X to the power of 3 over 2, we've got 2 of them, so it's 2x to the power of 3 over 2. And x, just in its own, we're just leaving it as x. Make sure you have dx right the way down. Make sure you have your integral signs right the way down. From here, you can now integrate. X is not in the bottom of a fraction, and there are no square roots, cube root signs, etc. So, integrating. Integrate x squared, add 1 to the power, it goes to x to the power of 3, divide it by 3. 2x to the power of 3 over 2, add 1 to the power, so 3 add 2 is 5, so it's 5 over 2. Divide by that new power, remember the 2 would just stay as it is. X is x to the power of 1, so add 1 to the power, it goes to x to the power of 2 over 2. And remember, your plus c. From there, tidy this up a bit. Dividing that by 3, we can't really simplify. Dividing by 2, we can't simplify. If you divide by the 5 over 2 though, remember you could write it a slightly different way. It's the same as flip that upside down and change it to times. So we're timesing by the 2/5, which means then you would have x cubed over 3 plus 2 times the 2 would give you 4 over 5, and we've got the x to the power of 5 over 2. X squared over 2 would stay as that, and then we've also got that plus c, so that would be your answer. Example 12. Integrate x cubed plus 3 over x squared. So with this one, again, looking at it, we've got x in the bottom of a fraction. We can't have x in the bottom of a fraction when we integrate, so we need to rewrite it. You can do this 2 different ways. So either you could think, if I've got the x cubed plus 3, divide by x squared, what I'm really doing is I'm dividing the x cubed by x squared, and I'm also dividing the 3 by x squared. So you can split that up. So you could write it as that. From there, you can then simplify. So x cubed divided by x squared, it's the same base you're dividing, so subtract the indices, that become x to the power of 1. Here, if you've got 3 over x squared, well, x can't be on the bottom of a fraction, so move that up to the top, and it becomes 3x to the power of negative 2. So that is what you'd end up with. You could also have said, right, well, if I move the x squared up to the top line, it would become x to the power of negative 2. And from there, you're really multiplying both of these terms by x to the power of negative 2. So you could also have said, don't do both, just pick one, whichever one you like. But you could have said, that's x cubed plus 3 times the x to the power of negative 2 dx. So either split it up, so you're dividing both terms by x squared and then simplify, or take the x squared up to the top line and just multiply it with your brackets. X cubed times x to the power of negative 2 would become x. 3 times x to the negative 2 is 3x to the negative 2. Either way, from there we can now integrate. There are no roots, x is not in the bottom of a fraction, so add 1 to the power. That would give you x to the power of 2 divided by 2. And 3x to the negative 2, add 1 to the power, goes to negative 1, divide by that negative 1, that's what you get. And remember, when you integrate, you need plus c. From there, you can say, well, that would stay as x squared over 2, or you could write half x squared. Because you've got the negative at the bottom here, just move that out to the side, so you end up adding a negative, or in other words, you're just taking away, and then that stays as 3. But you can put the x just on the bottom. It's x to the negative 1, so you can move that down, so it's 3 over x. And again, plus c. You always need your plus c. Next one. Example 13. This time we're integrating x minus 4 over root x. So again, you can't integrate when x is in the bottom of a fraction. You can't integrate again when there's root signs. Here we've got the square root, and it's also in the bottom of a fraction, so we need to rewrite it. So you could think, I'm dividing x by root x. I'm dividing 4 by root x, so just split that up. Remember, the square root means to the power of a half. So x over x to the half, take away 4 over x to the half. Doing that, I've got x to the power of 1 divided by x to the power of a half. Same base, so subtract the indices when you divide. So it leaves me with x to the half. 1 take away half, it's just a half. After that, you're taking away 4 divided by x to the half. Well, you've got no choice but to move that up to the top line. If you do that, it becomes negative a half. So x to the power of a half, take away 4x to the negative a half. Remember, just like example 12, you could have done it a different way. You could also have moved that root x up to the top line, and in doing so, well, that's x to the power of a half, so you'd be multiplying the x minus 4 by x to the power of negative a half. Again, with respect to x, you need your dx. Again, go one way or another. From there, you can add 1 to the power and divide by the new power. So 1 add 2 is 3, so you'd have 3 over 2. Divide by the 3 over 2. Take away 4 times, add 1 to the power, so negative 1 add 2 is 1, so that's 1 over 2. Divide by the half, and don't forget plus c. After that, well, if you divide by 3 over 2, flip the fraction upside down, change it to times, so it'll become times by 2/3. And same with the half. Flip that upside down, so dividing by a half is the same as timesing by 2, but because you've already got the number there, it becomes 4 times 2, which gives you 8x to the power of a half. And you need plus c. Last one, example 14. Integrate x times 5x minus 3 over the square root of x. Again, you can't integrate when x is in the bottom of a fraction or when you have any root sign. So here we've got the square root and x is also on the bottom of a fraction. So rewrite this as x to the power of a half. Also multiply out your brackets at the top as well. So 5x times x gives you 5x squared, and 3 times x gives you obviously 3x. We're subtracting the 3x. So multiply out the brackets at the top, rewrite that as x to the power of a half. We're not integrating yet, so make sure you've got the integral sign and dx. From there, you could do this 2 different ways, similar to example 12 and 13. I've just gone one way this time, but because I've got the 5x squared over x to the half, I'm dividing by x to the half, but I'm also dividing the 3x by the x to the half, so you can split that up so you've got the 2 separate fractions. If you do that, simplify there, so 5 would stay as it is, x to the power of 2 divided by x to the power of a half, same base, so subtract the indices. 2 take away a half is just really 1.5, or 3 over 2. You've got take away, 3 stays as it is, and x to the power of 1 divided by x to the power of a half, same thing, it's the same base, so would subtract the indices. 1 take away a half would just give you a half. You could also have taken the x to the power of a half up to the top line, so it would become this in brackets times x to the power of negative a half. Multiplying out the brackets would give you just this part here. It gives you the same thing. After that, you're then wanting to think, can I integrate yet? X is not in the bottom of a fraction. I don't have any roots. So yes, you can integrate. Woohoo! If you do that, you would add 1 to the power, so 3 over 2. Start with the top. Add the bottom, so 3 over 2, add 1 gives you 5 over 2. Remember to divide by the new power, so you're dividing by 5 over 2. You're taking away 3x to the power of, add 1 to the power, so a half add 1 gives you 3 over 2, and divide by the 3 over 2. And remember, what do you need, Grace? Plus c! Yes! After that, if you divide by the fraction, turn the fraction upside down, change it to multiply. So really, you'd be multiplying by the 2/5. The 5 times 2/5, well, the times by 5 and the divide by 5 would cancel out, leaving you with just the times by 2. Same here, if you've got 3 times the 2/3, well, you're timesing by 3, you're dividing by 3, so it would leave you just with the 2 and obviously the negative, and plus c would stay as plus c. That's 14 examples with integration. That's how you would integrate. Hopefully that makes sense. Feel free to look back at any of the examples. Anything you're unsure of, let me know. But try some of these questions. There are 3 exercises just in the Heinemann book on page 169. Just make sure though that whenever you integrate, you're writing your integral sign and dx before you integrate. You need that. And after you integrate, what do you always need? Say it with me. Plus c! You got it. Have fun.